Hi all, welcome to Code Studio. Myself Pawan. Today I'm going to explain the pivotality of the GFG. So the title is BST maximum difference. So here goes the flow of the question. You are given one binary search string and a target value. You must find the maximum difference between the sum of node from root to target and from target to child leaf node with excluding the target. Initially, we are starting at root. This is a basic one, and we are given one note that is if the target node is not present, then we should return -1. This will handle the base case. So, he has given one example one, and I will take you to the whiteboard in order to understand the question through this example. Okay, here he has target given as 20. So, what he is expecting from us is he is expecting the difference between from root node to this target node. So what would be sum excluding this 20 is 25. We should not include this because in note has given to exclude the target element. So we have to calculate the sum from uh, root node to target excluding the target. So that is 25. So difference between this and so sum between from target to root node. So we have to start from the target and we have to reach the leaf node. So this and this. So these two are the least nodes or leaf nodes at the bottom below this target element. So we have to he has again given one thing that is not to return the maximum difference. So in order to get the maximum difference, so this part what I am getting here should be minimum. So in order to get the minimum, so we have two options here, either to get 15 or to get 20t, or to return 22 from this. Either we should return this or we should take this leaf node. So in between these two, which one we have to take? The option is we have to take the minimum element that is 15. So our answer will become 10. So that is what he has given in this uh, answer, that is output as step. So this is the question. And one more thing is he has given, if has given target as 50, so it is nowhere present in every node. If we check, there is no element with value this 50. So in that case, you have to return -1. That is the base case we landed. And one more thing is, what if the target element is 35? What if my target element is 35? So again, I will calculate the same thing right from the root to the target. I will calculate the sum, that will be 25 again, minus. Here comes the interesting thing. So if you are at the root node, so from the root that is from the target node, you have to get the minimal element in order to maximize our difference. So in order to get the minimum element, what you should return from here and what will return from here, you should take minimum of those two. So if you consider here, if you consider the sum of the left subtree, 30 plus 32 will give you 62. And here if you see, the return value will be 45. Which is minimum? Is 45 will be the minimum. So our answer will be -20. So here we can come to the conclusion that we cannot change the sum from the target to the root node in order to maximize our difference. That is the final result. So we can calculate first our sum from the target to the root node, excluding the target as given in the node. And next, what we can do, what is in our hands to maximize the difference is from the target node. If you are returning, if you look and down of the tree, right from the target node, if you look at the down, you should collect the minimum between the left value and the right. Should collect the minimum value sum of the left subtree and the right subtree. That is what we are doing. That is the conclusion, that is the final conclusion. What we are going to do, that is the process. We have to collect the minimum value of the sum, right from the left subtree and from the right subtree. In both of this we have to collect the minimum, and we have to subtract it from the sum which is from root node to the target. So that is what we have to do. In order to do this, what we have to do is we have to first find the sum from the target to the root node. So, since it is given as a binary search tree, you can easily go to iterative approach or recursive approach, whichever you want. You can go through that. So, since it is a binary tree, oh, I gone through one iterative approach, like if my target element is less than that particular root node or current node, I will move to the left. If it is greater than, I will move to the right. So in this way, I got through iterative approach to find the sum from the root node to that particular target node. And after that, what I did is I collected the minimum sum right from the left subtree and the right subtree down of the target node. With the help of the recursion, I can do even with the help of the iterative, whatever it may be. So here, if you see, if you see the flow, this is my main function. Okay. So first of all, what I should check is whether my target node is present in T or not. So that we can get to know whether if it is present, then we can go through those, or we'll simply return -1 as given in the note. So through the iterative approach, see here I'm finding this particular target node is existing or not. So we can go through the binary subtree, and you can start seeing each and every subtree whether it is current node is less than or current node is greater than, so that you can move your current node. So in that way you can find, after knowing your target node is existing and you are returning the target node from the search function, our target is again to find the R sum, that is from root node to the target node. So this I said I followed here is the iterative approach. So it is very simple, quite obvious in binary search tree. If any element we are searching, if current node is greater than the target node, we'll just move to the left side. If it is less than, we move to the right side. So this is very simple iterative approach I followed to find the awesome. And another thing is from target to the root node, I followed the iterative approach. Here you can see I am returning the minimum element right from the right subtree and the left subtree. So that is the main intuition of this question, to find to return the minimum sum from the right subtree and the left subtree. Yeah, that we can do, and I'll try running it. Okay, we'll try after submitting. Yeah, it is. Yeah, thanks for watching.